Our solar system is not just a collection of planets, moons, and stars. It's a vast cosmic stage where the unimaginable becomes reality. Picture this: storms that rage for centuries, landscapes shaped by invisible forces, and icy worlds hiding secrets that could change everything we know about life itself. What if I told you that Saturn has a storm so precise it forms a perfect hexagon, or that distant Pluto carries a heart-shaped mystery frozen on its surface? These are not just scientific curiosities, they are puzzles that defy logic and demand exploration. In this video, we're diving into 30 of the most bizarre discoveries that have left scientists in awe and our understanding of the universe forever transformed. From volcanic moons to interstellar visitors, each finding peels back another layer of the solar system's infinite enigma. So, buckle up as we traverse the extraordinary, uncovering the secrets of worlds both familiar and alien, because the truth out there is far stranger than fiction. Now turning to one of the most mesmerizing and unusual sights in our solar system, let's explore the bizarre hexagon-shaped storm on Saturn's North Pole. Discovered by the Voyager spacecraft back in the 1980s and later studied extensively by the Cassini mission, this geometric phenomenon is unlike anything observed elsewhere in the cosmos. Imagine a storm so vast it could fit 4 Earths inside it, spinning in sync with Saturn's rotation, yet maintaining a nearly perfect 6-sided shape. Scientists believe jet streams, which are high-speed winds, play a significant role in creating this hexagonal pattern. These winds may interact with the planet's atmosphere in ways that amplify and stabilize the shape over time. Another theory suggests that gravitational waves may contribute to this precise symmetry, adding an extra layer of intrigue. What makes it even more mysterious is its persistence. This storm has raged for decades, if not centuries, without losing its striking structure. The vibrant images captured by Cassini reveal Saturn's hexagon in incredible detail, showing swirling clouds and dynamic patterns within the shape itself. It's a natural wonder that challenges our understanding of planetary weather systems and raises countless questions about the forces at work in Saturn's atmosphere. With such a unique and enduring feature, it's no wonder this storm continues to captivate scientists and stargazers alike. Moving forward, we head to the far reaches of the solar system to uncover another breathtaking anomaly, a heart-shaped wonder on Pluto that turned our perceptions of this icy world upside down. Now turning to another extraordinary discovery, let's travel billions of miles away to the distant dwarf planet Pluto, where a monumental feature captured humanity's imagination, a massive heart-shaped glacier called Tombaugh Regio. This iconic landmark was revealed in stunning detail by the New Horizons spacecraft during its historic flyby in 2015. Stretching over 1,000 miles across, the bright, reflective surface of this icy glacier made it an instant symbol of Pluto, showcasing a world far more dynamic and complex than previously believed. What makes Tombaugh Regio so unique is not just its shape but the story it tells about Pluto's geological history. Its reflective nature indicates a surface composed mostly of nitrogen ice, and the lack of impact craters suggests it is geologically young, possibly less than 10 million years old. But the surprises don't end there. Scientists discovered evidence of convection within the glacier, meaning the nitrogen ice is slowly churning and renewing itself over time, a phenomenon driven by heat from Pluto's interior. Even more fascinating is the potential presence of a subsurface ocean beneath this icy crust, raising the tantalizing possibility that Pluto, once dismissed as a cold and lifeless rock, could harbor conditions suitable for life under its frozen surface. Tombaugh Regio has not only reshaped scientific understanding of this distant world, but it also challenges assumptions about what icy, far-off celestial bodies might hold. Who would have thought that such beauty and mystery could exist on a planet so remote? And as we marvel at Pluto's heart, our journey takes us to yet another remarkable destination, a volcanic world unlike any other in our solar system, Jupiter's moon Io, where fiery eruptions rewrite everything we know about planetary activity. Now turning to a world of intense and fiery activity, let's explore Jupiter's moon Io, a place that redefines what it means to be geologically alive. Io is not just any moon, it is the most volcanically active body in the entire solar system. This is a world where the surface is constantly reshaped by massive eruptions, with lava flows that can stretch for hundreds of miles. So, what fuels this relentless volcanic activity? The answer lies in Io's unique relationship with Jupiter and its neighboring moons, Europa and Ganymede. As Io orbits Jupiter, it is subject to intense gravitational forces that stretch and squeeze the moon in a process known as tidal heating. This frictional heating generates enormous amounts of internal energy, melting its interior and fueling the volcanic eruptions that dominate its surface. Scientists have observed lava fountains that can shoot molten rock dozens of miles into the air and volcanic plumes rising so high they can be seen from space. The colors of Io's surface, shades of yellow, red, and white, are a testament to the richness of sulfur and sulfur dioxide spewing from these eruptions. These dynamic processes give us a window into how tidal forces can transform a celestial body, providing clues about geological activity on other moons and planets. The incredible forces shaping Io also offer insights into heat generation and redistribution within celestial bodies, potentially informing theories about tectonic activity and habitability in other parts of the cosmos. As we leave the firestorms and glowing lava lakes of Io behind, our journey takes us to another fascinating phenomenon, a place where icy jets erupt into space, hinting at a hidden ocean beneath. This is Jupiter's moon Europa, and its mysterious water plumes could hold clues to one of the most profound questions in science: whether life exists beyond Earth. Now turning to Jupiter's moon Europa, we encounter a discovery that has sparked immense scientific curiosity: water vapor plumes erupting into space. This icy moon, with its smooth and reflective surface, hides secrets beneath its frozen crust. Evidence from the Galileo spacecraft and the Hubble Space Telescope has revealed these towering jets of water vapor, providing tantalizing clues to what lies below. Scientists believe that beneath Europa's icy shell exists a vast subsurface ocean, containing more water than all of Earth's oceans combined. The detection of these plumes is more than just a geological curiosity. It is a potential game changer in the search for extraterrestrial life. These eruptions suggest that the ocean beneath Europa's surface might be interacting with the moon's rocky core, creating the kind of chemical environment that could support life. Imagine the possibility of liquid water, energy sources, and organic compounds coexisting under the ice conditions that are considered essential for life as we know it. Missions like the upcoming Europa Clipper aim to study these plumes in greater detail, analyzing their composition and searching for signatures of life. If such missions confirm even the faintest biological traces, it would forever change our understanding of life in the universe. From the icy shell and mysterious plumes of Europa, our journey takes us to a moon with rivers and lakes not of water, but of hydrocarbons, a world that redefines what it means to have a hydrological cycle. Let's explore the alien landscape of Titan, Saturn's largest moon. Moving forward, we arrive at Titan, Saturn's largest moon, and a place that defies everything we thought we knew about planetary environments. Here, rivers and lakes are not filled with water, but with liquid methane and ethane, a truly alien hydrological cycle unlike anything on Earth. Thanks to data from the Cassini mission, we now know that Titan's atmosphere, thick with nitrogen and hydrocarbons, supports a weather system where methane clouds form, rain falls, and rivers carve the moon's surface. This creates lakes and seas that eerily mirror those on our planet, but instead of water, they are composed of hydrocarbons. Imagine standing on the shores of one of Titan's lakes, gazing at a horizon that looks familiar in form but is entirely alien in substance. Titan's surface temperature is so low that methane and ethane, which are gases on Earth, exist as liquids, driving a hydrological cycle that mimics our own but with compounds that are more commonly found in natural gas reserves. This discovery not only expands our understanding of planetary processes, but also raises profound questions about where and how life might exist. Could Titan's unique environment harbor some form of exotic life, adapted to liquid methane instead of water? Exploring Titan continues to push the boundaries of what we consider habitable, inspiring future missions like Dragonfly, a rotorcraft lander designed to study its chemistry and potential for life. As we leave Titan's strange and stormy landscape, our journey heads back to Jupiter, where a storm has been raging for centuries. A storm so vast and so powerful that it remains one of the most iconic features of the solar system. Now turning to Jupiter, we are met with a sight that has captivated astronomers for more than 300 years, the Great Red Spot. This colossal storm, spinning endlessly in Jupiter's turbulent atmosphere, is so vast that it could easily swallow the Earth. The tempest's swirling clouds and striking red hues have made it one of the solar system's most iconic features, yet it remains shrouded in mystery. The storm's tremendous size and intensity create extreme contrasts in temperature, with cooler clouds swirling at its center and hotter regions along its edges, hinting at complex and dynamic internal processes. Despite countless observations, scientists are still puzzled by its sheer longevity. While storms on Earth dissipate within weeks or months, the Great Red Spot has been raging for centuries, defying the limits of what we thought storms could endure. One theory suggests that Jupiter's lack of a solid surface allows the storm to feed on an uninterrupted supply of energy, while others point to the planet's powerful jet streams that stabilize and sustain the vortex. However, recent observations reveal an intriguing twist. The Great Red Spot is shrinking. Over the last century, the storm's size has decreased significantly, raising new questions about its future. Will this legendary storm eventually dissipate, or will it transform into something entirely new? By studying the Great Red Spot, we not only gain insight into Jupiter's complex atmosphere, but also deepen our understanding of fluid dynamics and weather systems, even on our own planet. As we leave the mesmerizing chaos of Jupiter's Great Red Spot, our journey will take us to Venus, where the planet's extreme conditions reveal an astonishing tale of runaway greenhouse effects and a rotation that defies conventional planetary behavior. Now turning to Venus, we encounter a world that challenges our understanding of planetary science with its extreme and contradictory characteristics. Venus, often called Earth's twin due to its similar size and composition, is anything but a sibling when it comes to its surface conditions. The planet's runaway greenhouse effect has created an atmosphere so thick with carbon dioxide that it traps heat on an unimaginable scale, making Venus the hottest planet in the solar system. Surface temperatures soar to nearly 900 degrees Fahrenheit, hot enough to melt lead, while clouds of sulfuric acid swirl overhead, forming a toxic and reflective shroud. This intense greenhouse effect not only illustrates the devastating power of unchecked atmospheric changes, but also serves as a stark cautionary tale for our own planet's climate. Yet, Venus's mysteries do not end there. Its peculiar rotation defies conventional planetary behavior. Venus rotates backward, meaning the Sun rises in the west and sets in the east, a phenomenon astronomers refer to as retrograde rotation. Adding to the enigma, a day on Venus, the time it takes for the planet to complete one full rotation, is longer than a Venusian year, the time it takes to orbit the Sun. These baffling dynamics suggest a violent past, possibly influenced by massive impacts or gravitational interactions that altered its spin. The extreme conditions and the planet's unpredictable rotations pose significant challenges for exploration. Landers and probes sent to Venus must withstand crushing atmospheric pressures and searing heat, making Venus one of the most inhospitable places to study in the solar system. Nevertheless, understanding Venus is crucial as it offers valuable insights into planetary evolution, climate science, and the potential consequences of atmospheric imbalances. As we depart from this hostile yet captivating world, our exploration leads us to the mysteries of an interstellar visitor that left its mark on our solar system, Oumuamua. Moving forward, we arrive at one of the most puzzling mysteries of recent times, an interstellar visitor named Oumuamua. In 2017, astronomers detected this strange object as it zipped through our solar system, marking the first time we've ever observed something of interstellar origin passing through our cosmic neighborhood. Unlike anything seen before, Oumuamua defied expectations. Its elongated, cigar-like shape was unlike typical asteroids or comets, sparking intense curiosity among scientists. Even more bizarre was its behavior. Unlike comets, it lacked a visible tail or the telltale gas emissions one would expect as it passed close to the sun. And yet, its trajectory suggested some form of acceleration, as if it were being gently pushed by an unknown force. This anomaly fueled debates about its nature. Was it simply an odd-shaped asteroid from a distant star system? Could it be a new type of comet with properties we don't yet understand? Or, as some speculated, could it even be an artificial object, perhaps a probe from an advanced alien civilization? While there's no consensus, Oumuamua has opened a window into the mysteries of interstellar objects and raised questions about what else might be wandering the vastness of space. This enigmatic visitor reminds us how little we know about the universe beyond our solar system, sparking excitement for future discoveries. As we ponder the mysteries left by Oumuamua's fleeting visit, we turn our attention to Mars, where evidence of ancient river valleys tells a story of a watery past. Now turning to Mars, we uncover a discovery that has reshaped our understanding of the red planet, its ancient river valleys. These dried-up channels and deltas, etched into the Martian surface, are powerful evidence that water once flowed abundantly across the planet. Images and data collected by orbiters and rovers reveal vast networks of valleys, suggesting a time billions of years ago when Mars had rivers, lakes, and perhaps even oceans. This watery history is not just a geological curiosity. It holds profound implications for the possibility of ancient life on Mars. Where there is water, life, as we know it, has a chance to thrive. These riverbeds may have served as habitats for microbial life in Mars' past, sparking a wave of scientific exploration to uncover more about the planet's history. Missions like Perseverance are at the forefront of this search, diligently exploring ancient lake beds and delta deposits. This rover is equipped with cutting-edge technology designed to analyze the soil and rock for organic compounds and other signs of past life. It is even collecting samples to be returned to Earth by future missions, promising unparalleled insight into Mars' ancient environment. The discovery of these river valleys is more than just evidence of water. It is a tantalizing clue in our quest to answer one of humanity's greatest questions: are we alone in the universe? With each step forward, Mars continues to reveal its secrets, drawing us closer to understanding its enigmatic past. As we leave the mysteries of Mars behind, we venture into the Martian skies to witness a phenomenon that is both stunning and surreal: the captivating blue sunsets of the red planet. As the next chapter of Mars' story unfolds, we are greeted by an extraordinary sight that defies expectations: the mesmerizing blue sunsets of the red planet. While Mars is often associated with its reddish hues, its sunsets tell a different story. Unlike on Earth, where sunsets glow in shades of orange and red, the skies of Mars display a tranquil blue as the sun dips below the horizon. This stunning phenomenon is the result of Martian dust in the atmosphere. The fine particles are just the right size to scatter the blue wavelengths of sunlight more effectively, creating this ethereal spectacle. Beyond its beauty, the blue sunset is a window into Mars' atmospheric composition and behavior. By studying how sunlight interacts with the planet's dust and atmosphere, scientists gain valuable insights into its weather patterns, wind dynamics, and even seasonal changes. These observations are not just about understanding Mars, they also help refine techniques for interpreting atmospheric conditions on other planets. For astrophotographers and scientists alike, the blue sunset stands as a reminder of the surreal and otherworldly beauty that awaits us in exploring alien landscapes. This rare view is a testament to both the uniqueness of Mars and the universality of physics shaping skies across the cosmos. With this captivating scene etched in our minds, we now shift our attention to the Moon, where a series of enigmatic discoveries challenge our understanding of Earth's closest celestial neighbor. Now turning to the Moon, our closest celestial companion, we uncover phenomena that are as intriguing as they are mysterious. Beneath the Moon's surface lie strange mass concentrations known as mascons that create unexpected gravitational anomalies. These dense regions, discovered during early lunar missions, are thought to result from ancient asteroid impacts that compressed the Moon's crust, leaving behind vast, buried structures of denser material. These mascons disturb the Moon's gravitational field, subtly altering the orbits of spacecraft passing overhead. This discovery not only deepens our understanding of the Moon's history, but also provides critical data for future lunar missions, ensuring safer navigation and precise landings. But the Moon's mysteries don't end there. Scattered across its surface are peculiar swirling patterns of bright and dark soil, often referred to as lunar twisters. These enigmatic formations appear almost like celestial brushstrokes, defying immediate explanation. Theories suggest that these patterns could be linked to localized magnetic fields left behind by ancient volcanic activity. Interactions between these magnetic fields and the solar wind streams of charged particles emitted by the Sun may have led to the gradual reorganization of surface dust, creating the distinct swirls we observe today. These lunar features not only highlight the complexities of surface dynamics on an airless world, but also hint at the Moon's magnetic past, a time when its core may have produced a stronger magnetic field. These discoveries remind us that even the familiar Moon holds secrets that continue to challenge and expand our understanding of planetary processes. As we marvel at these lunar enigmas, our journey now takes us to the ice giant Uranus, where an extraordinary tilt reshapes everything we think about planetary dynamics. Now turning to Uranus, the ice giant that defies conventional planetary norms, we encounter one of the most peculiar features in our solar system, its extreme axial tilt. Unlike any other planet, Uranus rotates on its side, with its axis tilted by approximately 98 degrees relative to its orbit around the Sun. This unique orientation means that one pole is often pointed directly at the Sun while the other is plunged into prolonged darkness, resulting in seasons that last over 20 Earth years. Imagine enduring decades of continuous daylight followed by decades of unbroken night. This is the reality for Uranus. Scientists believe this remarkable tilt could be the result of a titanic collision with an Earth-sized object billions of years ago, an event so catastrophic that it permanently altered Uranus's spin. Adding to the mystery, this sideways rotation creates unusual weather patterns and atmospheric dynamics. The planet's wind speeds, which can reach over 500 miles per hour, behave in ways that are still not fully understood, creating stripes and storms across the icy, blue-green expanse. Uranus's tilt not only reshapes how we think about planetary dynamics, but also offers valuable insights into the chaotic processes that shaped our solar system in its early years. As we unravel the mysteries of this sideways world, our journey now leads us even farther out to Neptune, where colossal storms and enigmatic dark spots await our exploration. Now turning to Neptune, the distant gas giant shrouded in deep blue mystery, we encounter its fascinating dark spots, colossal storms that materialize and vanish without warning. These massive, shadowy vortices, first observed by the Voyager 2 spacecraft during its flyby in 1989, remain some of the most perplexing features in our solar system. Unlike the Great Red Spot on Jupiter, which has persisted for centuries, Neptune's dark spots are transient, appearing and fading over just a few years. These storms are similar in size to Earth and are believed to be areas of high-pressure systems, in stark contrast to the low-pressure systems that characterize storms on our own planet. What makes them particularly intriguing is their dynamic nature, with winds that can reach up to 1,300 miles per hour faster than any wind measured on another planet. Scientists hypothesize that the dark patches highlight unique atmospheric conditions, potentially involving interactions between Neptune's frigid temperatures and its internal heat, which drive violent weather patterns. These storms also provide insights into the complex and chaotic weather systems that can emerge on a planet so far from the Sun, where sunlight is barely a factor. As we continue to study these ephemeral giants, they challenge our understanding of atmospheric physics and planetary climates, leaving us eager to uncover more secrets hidden in Neptune's turbulent skies. With Neptune's storms swirling in our minds, let us now voyage beyond the familiar planets to the icy realm of the Kuiper Belt, where a host of strange and enigmatic objects await discovery. Now turning to the vast and icy frontier of the Kuiper Belt, we enter a region teeming with mysterious and ancient objects that hold clues to the early history of our solar system. Located beyond Neptune, this sprawling, frigid belt is home to countless icy bodies, including dwarf planets, comets, and other enigmatic remnants from the solar system's formation. Among these, Haumea stands out as one of the most peculiar discoveries. Haumea is a dwarf planet with an elongated, almost egg-like shape, a feature caused by its rapid rotation, spinning so fast that a single day there lasts only about 4 hours. This unusual shape alone sets it apart, but there is more. Haumea also boasts a surprising feature, a unique ring system, the first discovered around a dwarf planet. This thin, icy ring has sparked intense curiosity among scientists, as it raises questions about how such rings form and remain stable in the low-gravity environments of small celestial bodies. Additionally, Haumea's surface glistens with crystalline water ice, possibly the result of past collisions that exposed fresher material beneath its outer layer. Together, Haumea and the Kuiper Belt challenge and expand our understanding of planetary science, shedding light on the complexity and diversity of objects that reside in the most remote corners of our solar system. As we marvel at the strange beauty of Haumea and its surroundings, our journey continues deeper into this icy expanse, where even more fascinating discoveries await to redefine what we know about the cosmos. Now turning to the intriguing world of the asteroid belt, we find ourselves captivated by the dwarf planet Ceres, the largest object in this region between Mars and Jupiter. What makes Ceres extraordinary are its brilliant white spots, features that have sparked both fascination and mystery since they were first observed by the Dawn spacecraft. These luminous patches, most notably found in a crater named Ocata, stand out starkly against Ceres' dark, rocky surface. Scientists initially puzzled over their origin, but further studies suggest that these bright areas are composed of salt deposits, specifically sodium carbonate, which likely emerged when briny water from within the planet seeped to the surface and evaporated. This process points to the possibility of subsurface liquid reservoirs, an astounding revelation for such a small and cold celestial body. Another intriguing theory posits that Ceres might host cryovolcanoes, volcanoes that erupt not with molten rock but with icy slurries of water, salt, and gases. If true, this would make Ceres a rare example of an active, evolving dwarf planet, reshaping its surface over time. These findings not only deepen our understanding of Ceres, but also open up exciting possibilities regarding the presence of liquid water and perhaps even the conditions for life in unexpected places. As our exploration of Ceres draws to a close, we set our sights on a distant moon that jets water into space, inviting us to ponder the mysteries of life beyond Earth. Moving forward, we arrive at Saturn's icy moon, Enceladus, a celestial body that has redefined our perceptions of where life might exist beyond Earth. Enceladus stunned the scientific community with its powerful geysers, ejecting water vapor, ice particles, and organic compounds into space through massive fractures near its south pole, often referred to as tiger stripes. This surprising discovery was made possible thanks to the Cassini mission, which flew through these plumes and analyzed their composition in extraordinary detail. The detection of organic molecules, alongside evidence of liquid water beneath the moon's icy crust, suggests Enceladus harbors a subsurface ocean. Even more astonishing is that this ocean is believed to be in direct contact with the moon's rocky core, creating a potential environment for hydrothermal activity. This interaction between water and rock could provide the chemical energy needed to support microbial life, similar to what we see around hydrothermal vents deep in Earth's oceans. The plumes not only reveal the secrets of Enceladus' interior, but also offer a tantalizing glimpse into the possibility of life in one of the most unexpected locations in our solar system. With each passing discovery on this enigmatic moon, the excitement around future missions designed to search for signs of life continues to grow. And as we leave the frozen surface of Enceladus, we set our course for a planet that is slowly changing in an entirely different way, one that is shrinking as its fiery core gradually cools. Now turning to the smallest planet in our solar system, Mercury, we uncover a phenomenon that is both fascinating and perplexing. Mercury is shrinking. This discovery stems from the planet's gradually cooling iron core, a process that has caused the planet to contract over billions of years. As the core loses heat, it solidifies, reducing in volume and forcing Mercury's crust to wrinkle and buckle in response. These surface deformations, known as lobate scarps, appear as steep cliffs and ridges that stretch across the planet's surface. Some of these scarps rise to heights of more than 1 mile and extend for hundreds of miles, painting a dramatic picture of Mercury's geological evolution. The evidence of this contraction was first observed in detail by NASA, a messenger spacecraft, which orbited the planet and provided high-resolution images of these unique features. What makes this shrinking even more intriguing is that it's likely still happening today, making Mercury one of the few tectonically active planets in our solar system. This ongoing activity does not just reshape Mercury's surface, but also offers scientists a rare window into the processes that govern planetary cooling and contraction over time. By studying Mercury's geological history, researchers gain invaluable insights into the life cycle of rocky planets, lessons that could shed light on the evolution of Earth and other terrestrial worlds. As Mercury continues to evolve beneath its sun-scorched surface, its story reminds us of the dynamic processes that keep even the smallest of planets full of surprises. Moving forward, we venture from the heat of Mercury toward the blazing mystery of our very own star, where the sun's outermost layer defies logic with its inexplicably scorching temperatures. Moving forward, we set our sights on the sun, the life-giving powerhouse at the center of our solar system, where an enigma has puzzled scientists for decades: the sun's corona. The corona is the sun's outermost layer, a glowing halo of plasma that extends millions of miles into space. What is truly baffling is that this corona reaches temperatures over 1 million degrees, which is far hotter than the sun's actual surface, or photosphere, which averages around 10,000 degrees. This counterintuitive phenomenon defies basic thermodynamic principles, as one would naturally expect the temperature to decrease the farther you move from the sun's core. So, what's heating the corona to such extreme and astonishing levels? Scientists have put forth several theories to solve this cosmic mystery, and one compelling possibility involves what are known as nanoflares. These are tiny, rapid bursts of energy generated by the Sun's magnetic field, which may collectively transfer immense heat to the corona, essentially creating a superheated layer above the Sun's surface. Another intriguing hypothesis points to wave heating, where high-energy magnetic waves originating from the Sun's interior transport energy outward, depositing it as heat in the corona. To probe deeper into this perplexing mystery, NASA Parker Solar Probe has been launched to get closer to the Sun than any spacecraft in history. By braving the intense heat and radiation of the Sun's corona, this groundbreaking mission aims to collect unprecedented data on the Sun's magnetic fields, solar winds, and wave activity. The Parker Solar Probe is equipped to measure the very particles and energy flows that may unlock the secrets of this blazing paradox. Understanding the mechanisms behind the Sun's mysteriously hot corona isn't just an academic exercise. It holds profound implications for life here on Earth. The corona is the source of solar wind streams of charged particles that can interact with Earth's magnetic field, occasionally causing geomagnetic storms that disrupt technology and power systems. By unraveling the mysteries of the Sun's corona, scientists hope to predict solar activity more effectively, safeguarding the technologies that modern life depends on. Even as our understanding of the Sun deepens, the corona remains a dazzling reminder of how much we still have to learn about the forces that shape the universe. As we leave the mysteries of the Sun's outermost layer, we now shift our gaze beyond Saturn, where one of the solar system's most striking features is gradually fading the breathtaking rings of Saturn, which are slowly disappearing. Now turning to Saturn, we find ourselves marveling at one of the most iconic and mesmerizing features in the entire solar system, its breathtaking rings. These massive rings, composed primarily of ice particles along with dust and rock debris, have captivated humans for centuries, stretching hundreds of thousands of miles across but remarkably thin, only about 30 feet thick on average. They create a stunning visual spectacle around the gas giant. But here's the astonishing and bittersweet discovery: Saturn's rings are disappearing. Yes, these dazzling structures are not eternal. Scientists have uncovered that the rings are gradually being pulled into Saturn by its immense gravitational force in a process referred to as ring rain. Tiny ice particles within the rings are bombarded by ultraviolet light from the Sun, colliding with charged particles in Saturn's magnetic field. This interaction causes the icy material to lose energy and spiral down into Saturn's atmosphere, where it vaporizes. It is estimated that the rings are shedding material at an astonishing rate, with enough water to fill an Olympic-sized swimming pool raining down on Saturn every half hour. Researchers believe that, at this pace, the rings could vanish in as little as 100 million years, an unimaginably long time by human standards, but just a fleeting moment in the life of the solar system. While the loss of Saturn's rings is undeniably melancholic, it offers scientists a valuable opportunity to study planetary evolution in real time. The eventual disappearance of the rings will leave Saturn as a bare, ringless planet, similar to what we see today with Uranus or Neptune. This remarkable process raises fascinating questions about the formation and life cycle of such planetary features. Were Saturn's rings always this magnificent, or are we simply lucky to witness them at their peak beauty? Understanding how and why these rings diminish not only sheds light on the history of Saturn, but also deepens our understanding of the dynamic processes that shape celestial bodies across the universe. But as Saturn bids farewell to its rings over time, the mysteries of this planet certainly do not end here. Moving forward, we now venture to the far reaches of the solar system to discuss the tantalizing evidence of a hidden giant, a potential planet 9 that may be exerting its gravitational influence beyond Neptune. Moving forward, we venture into the icy darkness beyond Neptune, where hints of a hidden world have sparked one of the most intriguing mysteries of modern astronomy: the potential existence of Planet 9. This theoretical giant planet, estimated to be at least 5 times the mass of Earth, remains unseen, yet its presence is suspected due to the strange, unexplained gravitational effects observed in the outer reaches of our solar system. Scientists first began to suspect something massive was lurking far beyond Neptune when they studied a group of distant icy objects in the Kuiper belt, a region filled with small, frozen bodies orbiting the Sun. These objects display unusual, clustered orbits, as if they are being shepherded by an unseen force. This peculiar alignment cannot be easily explained by the known planets in the solar system, leading researchers to hypothesize the existence of a distant, undiscovered world exerting its gravitational influence. If real, Planet 9 would lie so far from the Sun that it would take an estimated 10,000 to 20,000 years to complete a single orbit, its distance and faintness would make it nearly impossible to spot with current telescopes, explaining why it has eluded us for so long. But the search is far from futile. Astronomers are continually refining their models and scanning the skies, hoping to catch a glimpse of this elusive planet. If Planet 9 is ever confirmed, it would revolutionize our understanding of the solar system, forcing us to rewrite textbooks and think differently about how planets form and evolve. Could it be a remnant from a time when the solar system was young and chaotic, or perhaps even a captured object pulled in from another star system? The answers could hold clues not just to our solar system's past, but potentially to the architecture of planetary systems throughout the galaxy. While the search for Planet 9 continues to push the boundaries of our knowledge, it also reminds us that the solar system remains full of surprises, with untold secrets waiting to be uncovered. And speaking of distant, icy worlds, our next stop takes us to the enigmatic dwarf planet Makemake, a realm with its own peculiarities and mysteries. Now turning to the shadowy world of Makemake, we encounter one of the most intriguing dwarf planets in the Kuiper belt. Located far beyond Neptune, Makemake is a realm of icy mysteries and strange contrasts. Despite its frozen surface, which is primarily composed of methane and ethane ice, Makemake is bafflingly devoid of any detectable atmosphere. This lack of atmosphere is particularly unusual given its icy composition and its size, which is comparable to or even larger than Pluto. The absence of a surrounding layer of gases challenges scientists' understanding of how atmospheres form and persist on such distant bodies. Adding to its mystique, Makemake has an exceptionally high reflectivity, meaning it reflects a significant amount of sunlight, making it one of the brightest objects in the outer solar system. However, its great distance from Earth presents significant challenges to exploration. Even with advanced telescopes, details about its surface and composition remain elusive, leaving much to speculation and indirect analysis. To make matters even more complex, Makemake's moon, known as MK2, complicates efforts to determine its exact properties, as the interplay between the two bodies affects observations of their movement and behavior. Studying Makemake and objects like it not only helps us understand these icy worlds, but also provides insights into the processes that shaped the early solar system. What secrets might this enigmatic dwarf planet hold, and could they shed light on the formation of other distant planetary systems? As we continue our journey through the solar system's most bizarre discoveries, the mysteries only deepen. Next, we turn to another exceptional member of the outer solar system, a moon that boasts a magnetic field, the remarkable Ganymede. Now turning to Ganymede, Jupiter's largest moon and a celestial giant in its own right, we encounter a discovery that truly sets it apart: its magnetic field. Ganymede is the only moon in the solar system known to generate its own magnetic field, a feature typically associated with much larger planets. This remarkable phenomenon was first detected by the Galileo spacecraft, and it has captivated scientists ever since. The source of this magnetic field lies deep within Ganymede's interior, where a liquid iron or iron sulfide core likely generates the magnetic activity in a process similar to Earth's own geodynamo. This discovery not only provides hints about the Moon's composition, but also raises fascinating questions about its geological history and evolution. Adding to the intrigue, Ganymede's magnetic field interacts with Jupiter's immense magnetosphere, creating dazzling auroras near the Moon's poles. These shimmering lights, visible in ultraviolet wavelengths, are not just a breathtaking sight, but also key to understanding the dynamics between Ganymede and its massive host planet. Moreover, this magnetic field may play a role in protecting a potential subsurface ocean beneath Ganymede's icy crust. Evidence suggests that liquid water could exist below the surface, making Ganymede a compelling candidate in the ongoing search for extraterrestrial life. The combination of its magnetic field, possible ocean, and a layered interior structure paints a picture of a moon that is far more complex and dynamic than previously imagined. As we marvel at this extraordinary discovery, we are reminded of how much there is to learn about the intricate relationships between moons and their planets. Moving forward, we delve into the reddish polar cap of Charon, Pluto's largest moon, and the fascinating theories surrounding its formation. Now turning to Charon, the largest moon of Pluto, we uncover a discovery as striking as it is mysterious: the reddish polar region famously known as Charon's red cap. This unusual feature was first observed by the New Horizons spacecraft during its historic flyby of Pluto in 2015, and it has puzzled scientists ever since. The red cap, located at Charon's north pole, is believed to be composed of tholins, which are complex organic molecules created when methane gas interacts with ultraviolet sunlight. But where does the methane come from? Surprisingly, it is thought to originate from Pluto's own atmosphere. Pluto's weak gravity allows tiny amounts of methane to escape into space, where some of it migrates to Charon and becomes trapped at the moon's freezing poles. Once there, the methane undergoes chemical transformations driven by sunlight, resulting in the reddish tholins that give the polar cap its distinctive hue. This discovery not only reveals a fascinating chemical interplay between Pluto and its moon, but also challenges us to rethink the dynamic relationships between celestial bodies in the outer solar system. Interestingly, the red cap may also contain clues about Charon's ancient atmosphere, suggesting that the moon itself could have once supported a temporary gaseous envelope. While more exploration is needed to confirm the full history of Charon's red cap, this discovery underscores the surprising complexity of even the smallest and most distant worlds in our solar system. With these insights into Charon's polar mystery, we now turn our attention to the interstellar dust particles that have found their way into our solar system, unlocking secrets of the cosmos itself. Moving forward, we delve into a discovery that bridges our solar system with the vastness of interstellar space: the detection of interstellar dust particles within our own cosmic neighborhood. These tiny grains, thought to have traveled immense distances from other star systems, were first identified by space missions like the Ulysses spacecraft and further studied by the Stardust mission. Unlike the dust originating from comets or asteroids within our solar system, interstellar dust carries the telltale signatures of its distant origins. By analyzing the composition of these particles, scientists have uncovered elements and isotopes that hint at the explosive deaths of stars, such as supernova, that occurred long before our solar system even formed. These visitors tell a story of cosmic recycling, where the remnants of ancient stars are repurposed into new celestial bodies, including planets like Earth. But how do these particles manage to infiltrate the protective bubble of our heliosphere, the vast region influenced by the solar wind? The answer lies in the interaction between the heliosphere and the surrounding interstellar medium, where occasional breaches allow these alien grains to slip through and reach our solar system. Equally fascinating is the mystery of cosmic rays, another interstellar phenomenon that intersects with our solar environment. These are highly energetic particles, often consisting of protons and atomic nuclei, that zip through space at nearly the speed of light. Cosmic rays are born in some of the most violent events in the universe, such as supernova explosions and interactions in distant galaxies. While they sound harmless, their energy levels are so extreme that they can pose a danger to astronauts and electronic equipment in space. Thankfully, our heliosphere acts as a protective shield by deflecting many of these high-energy particles, though some still manage to penetrate its boundaries. The study of cosmic rays not only helps us understand these invisible cosmic travelers, but also provides insights into the forces shaping our galaxy. Together, the discoveries of interstellar dust and cosmic rays reveal a fascinating dialogue between our solar system and the broader universe, connecting us to events and phenomena far beyond our celestial backyard. With these cosmic revelations, we now turn to an even more mesmerizing boundary, the solar system's bow shock, where our star's influence meets the vast unknown of interstellar space. With the next phase of the journey in sight, we arrive at the astonishing discovery of the solar system's bow shock, a boundary where the solar wind, a stream of charged particles emanating from the sun, collides with the interstellar medium, the vast space filled with gas and dust between star systems. This dynamic interaction creates a turbulent region that resembles a bow wave, much like the rippling water formed as a boat moves through a lake. However, unlike the familiar waves on water, the bow shock is an invisible frontier that can only be detected through the subtle changes it causes to charged particles and magnetic fields in space. Scientists believe this boundary acts as a protective shield, deflecting harmful interstellar particles and radiation, yet its exact nature remains elusive. Is the bow shock a sharp, well-defined edge or a more gradual transition zone? Recent data from space missions like the Voyager spacecrafts suggest that it might be more complex and variable than we originally thought, influenced by the constantly changing conditions of both the solar wind and the interstellar medium. This boundary represents the outermost reach of the Sun's influence, a place where our solar system's presence battles the forces of the galaxy beyond. What makes the bow shock particularly mesmerizing is its role as a cosmic frontier, reminding us of the vast unknown that lies just beyond our celestial neighborhood, a region that remains largely uncharted and brimming with secrets waiting to be uncovered. This awe-inspiring discovery brings us to the end of our journey through 30 bizarre discoveries in the solar system, a journey that proves our cosmic backyard is far stranger and more spectacular than we could ever imagine. With the next phase of the journey in sight, let us reflect on the extraordinary discoveries that have taken us from the mysterious Hexagon on Saturn to the heart-shaped glacier on Pluto, from the volcanic fury of Io to the geysers of Enceladus, and all the way to the solar system's bow shock at the edge of interstellar space. Each of these bizarre phenomena challenges what we thought we knew about our cosmic neighborhood, revealing a solar system alive with activity, complexity, and wonder. These findings not only reshape our understanding of the planets, moons, and other celestial bodies that share this space with us, but also ignite a deeper curiosity about the forces that govern the universe. They remind us that despite centuries of exploration, we have only just scratched the surface of the mysteries that await discovery. From the possibility of subsurface oceans harboring life to the peculiarities of magnetic fields and storm systems, the solar system invites us to continually question, learn, and reach beyond the limits of our knowledge. As we continue to push the boundaries of human exploration, who knows what astonishing revelations lie ahead? Perhaps the most bizarre discoveries are yet to come. Thank you for joining us on this incredible journey through the wonders of the solar system. Be sure to share your favorite discovery in the comments below. Give this video a thumbs up and subscribe to our channel for more breathtaking explorations of the cosmos. Together, let us keep looking up and uncovering the secrets of the universe.